Every time you type a prompt and AI spits out a video, most people call it magic and most tech coverage call it generative AI. Neither of those explanations tell you anything. The real answer is stranger than both. It's physics, specifically the same physics that explain why the ink spread when it hits the water, discovered in 1827, and once you understand that connection, you will never look at AI generated video the same way again. This is Quiet Shift, the signal beneath the noise. We are going to cover three things today. 1. How Clip taught machines to understand the meaning of two words. 2. How diffusion models use physics to turn noise into images. 3. How those two systems combine to turn the 8-word prompt into a video. No hand waving, just learned patterns, the actual mechanism. A machine has to understand what text actually means. Not the words, the meaning. In February 2021, OpenAI released a model called Clip, trained on 400 million image captions pair from the internet. Here what it learned to do. Imagine a giant invisible map. Every images, every sentence exists at a point on that map. Clip's only job during the training was to place matching pair close together. A photo of a dog to the word photo of a dog, photo of a burning building close to the fire and the smoke at night. It just did it by converting everything, images and text both into a vectors list of 512 numbers. Each number a coordinate on that map, and it used one training rule, matching pairs. Pushing their vectors close together, non-matching pairs push them apart. And that's it, repeated 400 million times. What emerged was something no one explicitly programmed. That map has started encoding the meanings. And here's the proof. Take a photo of someone wearing a hat and take a photo of the same person without a hat. Pass both through the clip. Get two vectors, subtract one from the other, and the resultant vector, when compared against thousands of words, line closest to the word hat. The model learned that mathematical difference between the two images equal to the concept that distinguishes them. And that's not pattern matching, that's understanding, and that the map, that sad space of meaning between the image and the word, is what makes the text to video possible. But Clip only goes in one direction. Text and images in meaning out, it cannot generate anything for that. You need physics. A botanist named Robert Brown looked at the pollen floating in water through a microscope. The pollen kept moving randomly in every direction with no external force. What was happening? Water molecules were hitting the pollen from all the sides simultaneously, thousands of random nudges per second. The result? A random walk through space. This became the Brownian motion, the same process that caused ink to spread in water, smoke in Dismas room, and perfume to fill an entire space of one corner. Diffusion models do exactly this to images. During training, you take a real image and add a random noise to it, step by step, 100 times. Each step, a random nudges to every pixel value. After 100 steps, the image is pure static, completely destroyed. Brownian motion applied to the pixels, and then you train a neural network to reverse it, to start from chaos and recover the structure. Here where it gets continuative. Your first instinct is train the model to remove the noise one step at a time. Remove 100 to step 99, step 99 to step 98. Berkeley's research team tried a different approach in 2020. Their paper, Denoising the Diffusion Probabilistic Model (DDPM), became the foundation for almost every image model that exists today. The instinct: don't train the model to predict the previous step, train it to predict the total noise added from the very beginning. The entire journey in one shot. To explain you, here's the analogy. Someone scrambled a Rubik's Cube with 100 random moves. Now, option 1, guess what the last move was, which is technically possible but noisy, hard to learn from. And option 2, figure out the complete solution back to solve the state. Sounds harder, but it gives the model a clear and stable signal, with less variance in training, faster learning, better outputs, and that's the DDPM inside. One more thing that seems wrong but it isn't. When the model generates an image, at every denoising step, it adds small amount of random noise back in. You just remove that noise, and why added it back? Because Without it, every generated image collapses to the same blurry average. Think of averaging the 1,000 photographs of tree. The result is smudged, grey, unrecognizable, mess. No specific tree, just the mean of all the trees. The re-injected noise keeps the model exploring the full distribution of possibilities. Sharp edges, specific details, genuine variations. The noise is not just corrupting the output. The noise is what makes the output real. Now bring both the systems together. You type your prompt, Clip converts it into a vector, a specific location on the map of meaning. The diffusion model starts with pure noise, and at every single denoising step it checks, is the image moving closer to where my prompt sits on the clip map? If yes, continue in the direction. If no, adjust your words, become a compass, and the physics runs backward, guided by meaning at every step. After 50 iterations, what was the random static has become exactly what you described. Not because the model memorized your prompt, because the model learned the full geometry of the image looks like, and your word told it where the geometry to land. So the next time someone tells you AI video generation is a black box, here's what actually happening. Clip built a map where meaning has the coordinates. Diffusion learned to reverse the Brownian motion to run the physics backward, and your prompt is the compass that steers the physics toward the right location on the map. And that's the signal beneath the noise, not mystery. It's from the physics from 1827. Running in reverse at scale, guided by the language. And this is the White Shift. See you in the next week.